What do you mean the final exam is cumulative?
What's that?
What do you mean the final exam is cumulative?
It's over everything.
That makes sense.
We'll start in 1 minute. We'll continue the final exam review by going over practice finals. The final exam is cumulative. That means that it's over everything that we've covered this semester. And then another reminder, the final exam is on Monday, starting at 3 p.m., Monday, May 3rd, and lasting for 2 hours. The final exam is on Newton, and you can take the practice final exam on Newton 3 times, but make sure you take it at least once so that you won't be surprised when you take the real final. Okay, we got to this problem on the first sample final exam. Solve the inequality 2x over x minus 7 is less than or equal to 1, and then give the solution in algebraic notation and interval notation. We want one side to be 0. So we have to subtract 1 from both sides. And then after subtracting 1 from both sides, we want to write the left-hand side as a single rational expression with a common denominator. So we in effect multiply by 1, multiply minus 1 by 1 in the form x minus 7 over x minus 7. And then once you have the common denominator, we can simplify the numerator. So make sure you're careful. So we have 2x minus x, which is x. And we're also subtracting negative 7, which is the same as adding 7. So that inequality, rational inequality, simplifies to this, x plus 7 over x minus 7. And so the endpoints are x equals negative 7 and x equals positive 7. We divide the number line into 3 separate intervals and pick a test point from each interval. So from the first interval on the left, pick a number less than negative 7. So I'll pick x equals negative 8. And then in this inequality, replace x with negative 8. In the numerator, negative 8 plus 7 is negative 1. In the denominator, negative 8 minus 7 is negative 15, or 1/15. But the inequality less than or equal to 0, this one is false. In the second interval, pick any number you want between negative 7 and 7. So I'll pick 0. Replace every x with 0. This time we get 7 divided by negative 7, which is negative 1. But negative 1 less than or equal to 0 is true. Okay, so we have no, yes. And then the third interval, pick a number greater than 7. So I'll pick x to be 8. And in the inequality, in the numerator, 8 plus 7 is 15. In the denominator, 8 minus 7 is 1. But 15 over 1 less than or equal to 0 is false. Okay, then the endpoints. Since division by 0 is undefined, we always exclude endpoints that come from denominators. So we automatically exclude 7 no matter what the inequality says. So graphically, we have a parenthesis at 7. And the other endpoint makes the numerator 0 and the denominator negative 14. But 0 divided by negative 14 is 0. And 0 less than or equal to 0 is true. So we include the endpoint negative 7. And so our solution in algebraic notation is negative 7 less than or equal to x, which is less than 7. And then the interval notation is bracket negative 7 comma 7 parenthesis. All right, in the next problem, number 30, solve the equation 5 over x plus 3 minus 2 over x minus 3 equals 2 over x squared minus 9. The least common denominator is just x plus 3 times x minus 3. When you multiply x plus 3 times x minus 3, we get x squared minus 9. So multiply every term on both sides by the least common denominator. So we'll write that out. X plus 3 times x minus 3 over 1 times 5 over x plus 3. And then minus x plus 3 times x minus 3 over 1 multiplied by 2 over x minus 3. And on the right-hand side, we can write the least common denominator as x squared minus 9 over 1 multiplied by 2 over x squared minus 9. And then we get cancellations, x plus 3 divided by x plus 3. So we're left with x minus 3 times 5. In the next product, the x minus 3 factors cancel. So we have minus x plus 3 times 2. And on the right-hand side, x squared minus 9 divided by x squared minus 9, those cancel. So we're just left with 2. Okay, then be careful with algebra and arithmetic. X minus 3 times 5 is 5x minus 15. And here we have to make sure that we subtract the entire product. We have to subtract 2 times x, so we write minus 2x. And we also subtract 2 times 3, or minus 6. And then combine like terms, we get 3x minus 21 equals 2. And then 3x equals 23. And then finally, x equals 23 over 3. So that is not a restricted value. Make sure that you're aware of the restricted values. So the restricted values are 3 and negative 3. Okay, the next page this is a problem on, it's all a single problem having to do with a quadratic function, the graph of which is a parabola. So the instructions say graph the parabola y equals negative x squared plus 2x plus 3 by using its properties. So in part A, does the parabola open upward or downward? Since the coefficient of x squared is negative 1, we know that it opens downward. So it will have that sort of shape. What is the axis of symmetry? Well, the axis of symmetry is the vertical line x equals negative b over 2a. That's the same number that is the x coordinate of the vertex. So we can see from this quadratic function that the value of b is 2 and the value of a is negative 1. So negative 2 over 2 times negative 1, or negative 2 over negative 2, or positive 1. So the axis of symmetry is the vertical line x equals 1. And then what is the vertex? Well, the x coordinate of the vertex is negative b over 2a. We already found that, so that's positive 1. And then to find the y coordinate of the vertex, we use the quadratic function as a formula. Replace x with 1. So negative 1 squared is negative 1 plus 2 times 1 is positive 1. And then 1 plus 3 is 4. So the vertex is the ordered pair 1, 4. And then in part D, find all intercepts and write the intercepts as ordered pairs. The y-intercept occurs when x is 0. And so from the quadratic function, when x is 0, the y-coordinate is 3. And then to find the x-intercepts, we replace y with 0. 0 equals negative x squared plus 2x plus 3. And then we solve this equation for x. So what I would do, since we have 0 equals negative x squared plus 2x plus 3, I would divide every term on both sides by negative 1. Having a leading coefficient that is positive is usually easier to work with. So since we're just solving an ordinary quadratic equation, we are permitted to do that. So 0 divided by negative 1 is still 0. Divide each term on the right-hand side by negative 1, we get x squared minus 2x minus 3. And we can solve this easily by factoring. One factor is x minus 3. The other one is x plus 1. And so the two solutions to this equation are x equals 3 and x equals -1. And so the x-intercepts written as ordered pairs are 3, 0, and the other one is -1, 0. Okay, now we can graph the parabola. And we have a formula for finding additional points if we want them or if we need them. Okay, so the vertex is the ordered pair 1, 4. So there's the vertex, 1, 4. The y-intercept is 0, 3. We have an x-intercept at 3, 0. And another x-intercept at -1, 0. So we can use symmetry to find other points if we want. Remember the vertical line of symmetry is x equals 1. So symmetric to the y-intercept is the point whose coordinates are 2, 3. Hey, but that's enough to sketch the parabola, at least roughly. Okay, in part F, says solve the inequality -x² plus 2x plus 3 is greater than 0. And write the solution in interval notation and algebraic notation. So this says we can use the graph in part E to find the solution to this quadratic inequality. So remember, this is the graph of y equals -x² plus 2x plus 3. Or you could think of it this way, -x² plus 2x plus 3 is equal to y. And then the inequality says we want -x² plus 2x plus 3 to be greater than 0. So that just means the domain interval where the y coordinates are greater than 0 is the solution to that inequality. So for which x values is y greater than 0? Well, look at the y-axis. The y values that are greater than 0 are the numbers above the y-axis, or above the x-axis. And the interval where the graph is above the x-axis is the open interval from -1 to 3. So if we use the graph, we can say that the solution to this inequality in algebraic notation is -1 is less than x, which is less than 3. And then in interval notation, it's parenthesis -1 comma 3 parenthesis. Okay, if that doesn't make sense to you, then you can solve the inequality the regular way. Find the endpoints by solving the equation, negative x squared plus 2x plus 3 equals 0. But we already did that above when we were finding the x-intercepts. So the endpoints are x equals 3 and x equals -1. So you can plot the endpoints -1 and 3, divide the number line into 3 separate intervals. And then we won't go through the whole process. I'll just point out in the middle interval, when x is 0, if we pick the test point x equals 0 in the middle, we get 3 greater than 0, which is true. And so all of the numbers between -1 and 3 are solutions. And I won't do the rest. I'll just say that if you pick a test point in the first interval, you'll get a false statement. Pick an interval from the third, or pick a test point from the third interval, you'll get a false statement. And since the inequality is strictly greater than, the endpoints are excluded. So all of the numbers between -1 and 3 are solutions. Okay, now we'll get started on the second sample final exam. Okay, first problem on this sample final exam. Solve the equation x squared plus 10x equals 3. Well, this is a quadratic equation. We have multiple ways to solve quadratic equations. So one way is subtract 3 from both sides, so x squared plus 10x minus 3 equals 0, and then use the quadratic formula. Another one is just to solve by completing the square. So if we do it that way, we create a perfect square trinomial. We take half of 10 and square it. Half of 10 is 5, and 5 squared is 25. So if we add 25 to both sides, then we get this equation. In the next step, we'll factor x squared plus 10x plus 25 and write it as x plus 5 to the second equals 28. And then apply the square root property, and we get x plus 5 equals positive and negative square root of 28. The square root of 28 can be simplified. So in the next step, we'll just write x equals -5 plus and minus. And then the largest factor of 28 that's a perfect square is 4. 4 times 7 is 28. But the square root of 4 is 2. So we have the two solutions. One is -5 plus 2 times the square root of 7. The other solution is -5 minus 2 times the square root of 7. This is the same set of solutions you would get if you used the quadratic formula. Okay, the next problem, find the vertex of the parabola, y equals -3x squared minus 12x minus 17. You can use the formula for the x coordinate of the vertex, which is negative b over 2a. And then when you know what that x value is, use the formula, the function, to find the y coordinate that goes with that x coordinate. Another way to do it is to go through the process to get the quadratic function in vertex form. So I'll review that here, since that is something that you should know how to do. So to get it into vertex form, we factor -3 out of the x squared term and the x term, but not the constant. So factor -3 out of the first two terms. We have -3 times the quantity x squared plus 4x, but leave the -17 on the outside. And you can check that you're doing it correctly by multiplying. -3 times x squared is -3x squared. -3 times 4x is -12x. Okay, in the next step, we add 0 and also create a perfect square trinomial. So inside the parentheses, we focus on x squared plus 4x. To create a perfect square trinomial out of x squared plus 4x, take half of 4 and square it. So half of 4 is 2, 2 squared is 4. So we add 4 and then subtract 4 to maintain equality. We're just adding 0. And then y equals -3. We keep the perfect square trinomial. So -3 times the quantity x squared plus 4x plus 4. Then use the previous step and apply the distributive property of multiplication over subtraction. -3 times -4 is +12. So we put the plus 12 together with the -17. And then the next step is the vertex form, -3 times the binomial x plus 2 squared minus 5. Okay, so the vertex is the ordered pair -2 for x and -5 for y. And number 3, use the AC method to factor 10x squared plus 19x minus 15. Okay, we're just factoring a trinomial by the AC method. We're not solving an equation. So in the AC method, we multiply 10 times -15, which is -150. And we want to see if we can find two integers that have a product of -150 and a sum of 19. So since the product is negative, one must be positive and one must be negative. And since they add up to +19, the one with the largest absolute value is positive. So if we start our systematic process, -1 times 150. The next pair is -2 times 75. Then -3 times 50. -4 is not an integer factor, but -5 is. -5 times 30. Those add up to 25, so we're getting closer. And then -6 times 25. -6 plus 25 is 19, so The two integers we want are -6 and 25. So transform the trinomial into a quadrinomial. Replace the plus 19x with minus 6x plus 25x. And then factor by grouping. Out of the first two terms, the greatest common factor is 2x. And then we're left with the binomial 5x minus 3. Bring down the middle operator of addition. And then out of the third and fourth terms, the greatest common factor is 5. And the binomial is 5x minus 3. And then the final step, 5x minus 3 times 2x plus 5. So that is the factorization. And number 4, find the restricted values of the rational expression x plus 3 over x squared plus 2x minus 24. To find the restricted values, we only need to focus on the denominator. So we want to know the x values that make the denominator 0. So x squared plus 2x minus 24. Set that equal to 0, and then we just solve the quadratic equation. So you are free to solve the quadratic equation using any method that you like. And we can solve this one by factoring. The two factors are x plus 6 and x minus 4. The solutions to the equation are -6 and positive 4. So those are the restricted values. -6 and positive 4 are restricted. That means they are not permitted to be used in that rational expression. Okay, then number 5, we have a quadratic equation, x squared plus 4x plus 12 equals 0. Find the discriminant and then classify the solutions. So remember a quadratic equation. Notice this one there's only the variable x in it. It's not a quadratic function. We don't have the variable y. We just have a quadratic equation. So the three possibilities for solutions are 2 distinct real solutions or 1 repeated real solution. And then the third possibility is 2 distinct non-real solutions. And the discriminant, b to the second minus 4ac, enables us to determine what sort of solutions we have. So in this one, b is 4, a is 1, and c is 12. So b to the second, 4 to the second, minus 4 times 1 times 12 is 16 minus 48, or -32. Okay, so since the discriminant is negative, remember the discriminant is what goes inside the square root in the quadratic formula, and the square root of a negative number is non-real. So when we classify the solutions, we just say 2 different or 2 distinct non-real solutions. Okay, so that's all you have to do on that one. problem 6, find the x-intercepts, if any, of the parabola y equals negative x squared minus 4x plus 96. So in an attempt to find the x-intercepts, if there are any, we always replace y with 0 and then solve for x. So 0 equals negative x squared minus 4x plus 96. We can use any method that we want to solve this quadratic equation. So I'm going to divide every term on both sides by -1 so that the arithmetic is a little easier. So I get 0 equals x squared plus 4x minus 96. And I think we can solve by factoring, but let's use the quadratic formula since we haven't done that yet today. So A is 1, B is 4, and C is negative 96. So x equals -4 plus and minus the square root of 4 squared minus 4 times 1 times negative 96. All divided by 2 times 1. So this is going to work out pretty nicely. So take a few seconds and then tell me what the solutions are that you get. So I'll give you 20 or 30 seconds. Okay, I got an answer online and in class. So let's go ahead and do the arithmetic. So inside the square root, 16 minus 4 times 1 times negative 96. So 4 times, well, this is going to become, since we're subtracting a negative, it's adding a positive. And 4 times 96 is 384. 4 squared is 16. 16 plus 384 is 400, which is a perfect square. The square root of 400 is 20. So one solution is -4 plus 20 over 2, or 16 over 2, which is +8. And the other solution, -4 minus 20 over 2. -24 over 2 is -12. So +8 and -12 are the two solutions. All right, the next problem, write the equations of the horizontal and vertical lines that pass through the point -3, 7 in the xy plane. and then label each equation. So in other words, label the vertical line equation through that point and the horizontal line. Okay, what's the equation for the vertical line that passes through the point -3, 7? Yeah, it has to be an equation. X equals -3. Yeah, so if you just say the number, that's not enough. We need x equals -3 for the vertical line equation. And then the horizontal line equation through that same ordered pair is y equals 7. All right, next page. Solve the inequality. This is an absolute value inequality. 10 is less than or equal to the absolute value of 6 minus 3x minus 2. So the first thing to do is get it into standard form by adding 2 to both sides. So when we add 2 to both sides, we get 12 is less than or equal to the absolute value of 6 minus 3x. So up here, I'll just remind you how to find the endpoints. So generally, when we solve inequalities, we find endpoints that subdivide the number line into separate intervals. So to find the endpoints, we solve an absolute value equation. So I'll just write this as the absolute value of 6 minus 3x equals 12. So I'll label what we're doing. We're finding the endpoints by solving this equation. If the absolute value of 6 minus 3x equals 12, then there are 2 possibilities. 6 minus 3x could be 12 if its absolute value is 12. But the other possibility is that 6 minus 3x is equal to -12. And then the solutions to those are the endpoints. So the first equation subtracts 6 from both sides. We get -3x equals 6. Divide both sides by -3, we get x equals -2. So that's one of the endpoints. In the other equation, we subtract 6, we get -3x equals -18. And then divide both sides by -3, we get x equals +6. Okay, so those are the endpoints. So we go through the same sort of process when solving inequalities, plot the endpoints, and then we pick test points from each of the intervals. The interval on the left, pick a number less than -2, so I'll pick x to be -3. And then in the inequality, so we have 12 less than or equal to the absolute value of 6 minus 3 times negative 3. So this is the same as the absolute value of 6 plus 9. So I get 12 less than or equal to the absolute value of 15. And that's true. So all of the numbers from negative infinity up to negative 2 are solutions. In the middle interval, I'll pick 0. And then we have 12 less than or equal to the absolute value of 6, because 3 times 0 is 0. This is false. 12 is not less than or equal to 6, so this is false. And then in the third interval, pick a number greater than 6, like x equals 7. And then 12 less than or equal to inside we have 6 minus 3 times 7. 3 times 7 is 21. 6 minus 21 is negative 15. But the absolute value of negative 15 is 15, so this is also true. Since the inequality for this absolute value is less than or equal, that means we include the endpoints. So graphically, we have a bracket at the endpoints to indicate that the endpoints are included. And then the algebraic notation for this solution is parenthesis negative infinity comma, this is the interval notation, parenthesis negative infinity comma negative 2 bracket, and then union bracket 6 comma infinity. This is the interval notation. And then the algebraic notation for the same set of numbers, x is less than or equal to negative 2, or x is greater than or equal to 6. So this is the algebraic notation. Okay, the next problem, how many ordered pairs solve the system? Is it consistent, inconsistent, or dependent? So make sure that you don't go beyond what is written. Notice that it's not asking for a solution. It's only asking how many ordered pairs solve the system. So if you have a system of 2 linear equations, there are 3 possibilities. There's one solution if the 2 lines intersect at a single point. There are no solutions if the 2 lines are parallel. And then the third possibility, there are infinitely many solutions if the 2 lines are the same line. Well, we can tell by looking that the slopes are different. So whenever the slopes of 2 lines are different, they have to intersect at exactly 1 point, right? So the slopes are different. So there's exactly 1 solution, 1 ordered pair solution. Okay, if that doesn't make sense to you, then you can solve the system and still come to the right conclusion that there's one solution. And if there's one solution to a system of two linear equations, then the system is consistent. A word that's not included but could be, this system is also independent. Okay, let's look at number 10. We can find the answer to number 10 pretty quickly. Write the expression 3x to the fifth to the exponent 3/5 in radical form. Okay, so we need a radical. The denominator of the exponent is 5, so that means the index of the radical is 5. And then inside the radical, well, we can do a couple of different things that are equivalent. We can put 3x to the fifth in parentheses and then put the outer exponent 3. If you don't want the parentheses, you don't have to have them, but you have to do something else. So in other words, the term 3x to the fifth all to the third is 3 to the third, which is 27, and then x to the 3 times 5, which is x to the 15th. So these are equivalent. Just make sure that if you write 3x to the fifth, you need parentheses around that term. Okay, we're out of time for today. We'll continue this tomorrow and probably also on Friday. So go ahead and sign in for attendance.
I wonder if I had a YouTube song. And someone loves to watch the video. Sometimes seems like the number of people watching is more than the number of people actually sign in. No, I've had comments from outsiders before, but evidently they don't always comment. It's watch.
So I won't be here on Friday.
Oh, you won't? Yeah, I'm getting married. So, yeah. So that's where I'll be. Start the spring break on. Yeah, it's time to spring break off, getting married. So, okay. And then I'll go on my honeymoon for spring break. But I'll have a couple of days when I get back. I'll probably just take a bunch of, I get back on the phone, go back up to the stuff, and try to go through all of it again. Okay. All right. Well, congratulations. Thank you. See you. Have a good one. Yeah. I'm actually going to steal a mask too, because the professors are very stingy about it.
Oh, okay.
So it's nice that you're not. Take it easy.